So, welcome back, Satoshi-san, to Multicore World. I lost count how many times you have honored me with your presence. So many years ago. Yeah, and I'm really pleased to report that you will stay a full 30 hours in New Zealand this time. So, and your comment last interview about feeling as a homey conference was very referred. So, how do you experience this new setup?
Well, I think that you have certainly, gone upscale in terms of the number of talks, the quality of speakers, the variety of efforts, variety of subject matters. So it's been, even though I'm here for like a day and a half, I'm already thinking that this trip has been worth it. Because not just being able to tell my story, I'm learning a lot. I can, there are a lot of new directions that people are seeking. Now we have exascale days, or now we have new objectives. Now we have AI, incoming AI. We have quantum, and new types of computing that's making inroads into this general HPC. So it's been really a great learning experience. So it's been well worth the ticket prices and the money that I've spent, not my own money, but of course, my travel money.
My question in technical side, fascinating presentation and the convergence between AI and exascale and quantum and IBM presenting a machine above Fugaku in the next number of years. But I'm tempted to ask, is that only a play game for large corporations, or in these days of generative AI, anyone can access? I mean, we know that we can play with quantum clouds these days, but how do you see the democratization of this convergence of HPC and quantum and AI?
Yeah, I mean, again, it's a fine balance because it's still, on one hand, quantum computers are very expensive. Most of our project money will be spent on, just funneling money left to right, giving it to our quantum computing commercial partners. So we get very little money as a result, despite the apparent large size of the budget. With AI, of course, it's more democratized, but there's a tension between these very large entities like OpenAI, Microsoft, or Google, Meta, etc., where still the only selected elite infrastructures have the ability to train these multi-trillion parameter models. So we were privileged to work with our partners, not just with ourselves, partners like DOE, labs like Argonne, and their trillion parameter consortium to be able to have the capability. But again, these are very confined to a privileged few. And that said, especially with AI, a lot of advances are being made, as was presented today in some of the presentations, that people are making a lot of headways by concentrating on how to improve the smaller models that can be trained on modest resources. So you don't need 100,000 node resources to train these, but you only need modest, a few hundred, maybe up to like 1,000, but still within reason. And can be obtained from if you have apply for a public grant, it's within the scope of reality. So whether the advances will be made with these smaller models is something that's really interesting, because if the smaller models proliferate, it's not just the training, but also it's the use of these models, which will put a lot less stress on the infrastructure, including being able to move the inference from the data centers to the edge. Right? So, so this will really democratize AI, but it remains to be seen whether all these efforts with respect to small models will pan out, or they're just academic exercises, they're just training for specific data sets. And in reality, we really need, these very large models, and that's where the large corporations go. Yeah.
Speaking about resources, which is a finite element, we have been discussing about optimizations and different things, but I wonder if we should go starts to the bottom, for example, topology. A colleague of you, Thorsten Hoffler, and also it was presented in the past Multicore World, a new networked topology, Polar Fly. Not sure if you are familiar with that.
Yeah. Well, you mean in terms of physical network topology to drive these training systems, again, it's not being well studied as people may think. So also there's a question of topology, question of the absolute bandwidth needed, question of like what's the granularity because there are hierarchies. When you think of any neural network training, there's a hierarchy of parallelism, like from tensor parallelism to pipeline parallelism. Then there's data parallelism, and then of course there are searches or even fine-tuning. So the lower you are, there's more demand on the network. But it's not clear how much there is and what's the best topology for it.
Are you exploring that?
Oh yeah, and also there's a question of so if you're just building a pure AI machine, then you can super optimize your workload. But as we have seen and also demonstrated, the true innovation in this new realm will not be just AI alone. They really have to be combined with advanced simulation capabilities, advanced data processing capabilities, not just to focus on AI training. And that's why the hyperscalers are not quite there yet, right? And that's why they're working with us. But to design from the standpoint of network topology, how can you design a network that's good for AI training and also good for many of these HPC simulation workloads, but still can be built within reasonable cost? Because what we're seeing is there are some commonalities, but there are some differences, and how to come to terms in order to satisfy the requirements of both seems like a big challenge.
Thank you very much, Satoshi-san, for your visit, and you're welcome to visit us again.
Hopefully, yes. Next year.
In Christchurch again.
Okay, so
17 to 21 February.
Next year, I may be able to report something more concrete with regards to our next machine, but we'll see.
That we were looking forward. Thank you very much.
Thank you.